Greetings, ladies and gentlemen. Welcome to lesson 1.4. This is our last lesson in Unit 1, page 28 from your big ideas, where we're going to again solve equations, but this time a little bit differently. We're going to apply what we learned to rewrite what we call literal equations. You're going to learn what those are in just a moment. Our essential question: how can you use a formula for one measurement and rewrite the formula for a different measurement? So, ladies and gentlemen, you should have taken just a small, brief amount of notes from the top of page 28. One, a literal equation. What is a literal equation? That's right, it's an equation with two or more variables. Okay, they're different variables this time. So when I say two or more, I should say different variables. Okay, how do you rewrite a literal equation? Well, you just solve for one variable in terms of the other or others. That's all you do. How do we do it? Well, put your pencils down. You don't need to write all this stuff down. Just watch and listen. You're not even going to write it down when I'm done. You're just going to listen because it's going to remind you. What have we been doing? We have been doing all of this. We have been simplifying by combining like terms, eliminating parentheses. Well, how do we combine like terms? Well, the same side we use a given operation, opposite sides, inverse operations. We eliminate parentheses by either dividing out the factor or distributing that factor across the parentheses. And most importantly, even with literal equations, we are going to isolate the variable that we want, and we're going to keep the equation balanced. It's all done the same exact way. So, leave your pencils down, watch and listen and learn, and then at the end of the video, at the end of the example, pick it up and pause and write it all down. So we're going to rewrite this equation. It's telling us solve this equation for y. It says y minus x equals 6. So we want to solve for y, which means we want y all by itself. We want y equals. So we have to take everything on the same side as the y and move it to the other side. Combine it with like terms, solving it, keeping it balanced, all those things that happen. All right, so the first thing I want to recognize is I got to take this x term, this negative x term, and I have to move it to the other side. Well, to move it to the opposite side of the equal sign, I have to use opposite or inverse operations. So I'm going to add x. Now, you're going to look at the other side, you're going to say, well, I don't have any other x terms. I can't just add it directly to 6. They're not the same terms. So you have to imagine, think about this. There is 0 x's on this side. And so I can actually add I can actually add x to 0 x's. The y would come down, the x and the negative x cancels out, and that leaves me with 6 plus x. We're done. Y equals, right there. Now I want to talk about something. This answer is absolutely 100% correct, but there is a more standard way of writing the answer that you want to get used to doing by putting the variable terms first in the answer. So when y equals, put the variable terms first. The x is positive, so is the 6. So rewriting that is as y equals x plus 6. If you have this answer, you're 100% correct. You will not be marked wrong. Ladies and gentlemen, pause the video, write it all down. Join me for example number 2. Welcome to example number 2, solving for y. Again, and you're going to understand later in the semester why we solve for y. No pun intended there. There is an absolute reason for solving for y, and you're going to learn it in a couple of weeks. So, ladies and gentlemen, solving for y plus 5 is equal to 2x. So once again, we want to solve for y, so we want it to say y equals something. So what are we going to do? We have to get rid of this 5 term. And again, on the other side, when we do the opposite, well, there is nothing to actually subtract it from, but there is a 0. We just didn't write it, so we can subtract it from 0. So the y comes down, that's 2x minus 5. Hey, the x term is already written first. We're done. We're absolutely done. That simple. Ladies and gentlemen, very straightforward. Very straightforward. Open your mind. Allow yourself to understand this. Ladies and gentlemen, pause the video, write it all down, and join me for example 3. Welcome to example 3. Again, solving for y. 5y minus x is equal to 10. Again, ladies and gentlemen, we're solving for y. We want to end up with y equals. So everything else has to go to the other side. And we use all the stuff we've been learning about isolating, keeping balance, inverse operations, all that stuff. So the first thing we recognize that we need to move is this negative x term. I need to move it to the other side. So I'm going to add x to both sides. Okay? So now 5y is equal to, and I always like to write the variable term first, so I am going to do that. X, that 10 is positive, so plus 10. Well, I'm not done because this says 5y. That doesn't say y yet. I still have to isolate that variable using inverse operations that says, hey, it's multiplied by 5, so now I have to divide by 5. Well, when I divide by 5, I have to divide both sides by 5. And both sides means every single term on both sides. So not only do I divide the x by 5, I have to divide the 10 by 5. Every single term is divided by 5. So this one cancels out, leaving you with y equals. Well, x divided by 5 is nothing more than x divided by 5. We can't do any more than that. But 10 divided by 5 is 2. So this is one of the answers. The other one that you could get used to, ladies and gentlemen, you should understand about terms. This variable term x does have a coefficient of 1. So I could write this as y equals 1/5 x plus 2. Instead of leaving that up there all by itself and making it look like that, I could say 1/5. Learning how to do this, these are equivalent. They are the same thing, and understanding that is going to help you when we get to Unit 4. So I'm just telling you, so pay attention to what we're doing. It all builds. Ladies and gentlemen, pick up your stuff, pause the video, write it all down, and join me for example 4. Welcome to example 4, again, solving for y. I'm telling you this is important. We're doing it a lot because it's very important down the road. So 4x minus 4y equals 1. We first recognize that we need to move that 4x term to the other side by subtracting it because it's positive. And so we get negative 4y is now equal to a negative 4x plus 1. Okay, we're not done. We got to get rid of that negative 4 right here by dividing by negative 4. And again, if you divide one side, you divide the other. And it says the side. That means the entire side. That means every single variable term on the other side. So I'm dividing this by negative 4, and I'm dividing the 1 by negative 4. All right, the two negative 4's simplify out, leaving me with y. Negative 4 divided by negative 4 is 1, so that leaves me with a positive x. And 1 divided by a negative 4 is negative 1/4. Or if you wanted to write y equals x minus 0.25, I suppose that would be okay, but this is the better practice to get into. Either one of those answers is acceptable. Ladies and gentlemen, pause the video, write it all down, and join me for example 5. Thank you for coming to example 5, solving for y. Again, 12 equals 6x plus 3y. So we recognize that we got to isolate y. We got to have y equals. So I'm going to take this 6x term first and move it to the other side. The inverse, because it's going to the opposite side, is to subtract 6x. So I get negative 6x plus 12 is equal to 3y. Well, I'm not done. I have to get rid of that 3. So I'm going to divide. That's the inverse opposite, dividing by 3. Doing it to both sides means every single term on both sides. So the negative 6x divided by 3 gives me negative 2x. And 12 divided by 3 gives me 4. And that's equal to y. So my final answer, y equals negative 2x plus 4. Either one of these ways is okay. You don't have to have the y all by itself on the left. But it doesn't matter. You can flip-flop the expressions on each side. It doesn't matter. It's the same thing. Ladies and gentlemen, pause the video, write it all down, and join me for our last example of this video. Solving for y, example 6, negative 2x minus 3y equals 9. Ladies and gentlemen, it's all the same stuff. It's all the same stuff. I really shouldn't have had to go through as many examples, but I really wanted you to see and understand. So once again, with your pens and pencils down, you are listening. You're doing it in your head with me now, and you're saying, hey, I got to end up with y equals. So everything that's not y has to move to the other side. I'm going to start with the negative 2x. To move it to the other side, I've got to do the inverse and add 2x to both sides. I end up with negative 3y is equal to 2x plus 9. I recognize I have to get rid of the negative 3, so I divide by a negative 3. Every single term on both sides of the equal sign. So a negative 3 divided by a negative 3 is 1 times y is y. 2 divided by a negative 3 is negative 2/3 x. And 9 divided by a negative 3 is negative 3. Wow. Pick up your pencil, write it all down, pause the video, and then go and copy down the equations for our quick writes. Ladies and gentlemen, it's only one equation. Solve that one for y. It looks a little bit crazy. Remember, combine like terms, all those things. Take a quick break. Take a mind break, get a drink, get a snack, and then come back and join us. Bye.